18. Okay, and Tyree, it's you, and it becomes up 14 as Jody. Okay. Now who's up first? H-N, number 18. According to section 0.5.
You want?
ln of x squared equals to, so for
You got to speak up. You got to speak more loud. Speak with more volume. Ln of
x squared equals to, so for x without using a calculating.
okay, solve without calculating utility.
It equals 4 because there's a 1 x squared equals 4.
Is that right now? Okay. What do you think, Mei-Chin? How? What do I do?
Use
Here's one way to approach it. You need to remember that the log base speed of a number is x, if and only if b to the x is the number. This is logarithmic form. This is exponential form. Okay? So these things go back and forth. What's the base here? What's the base? No, log would mean base 10. Log, common logarithm, log is base 10. When you have ln, it's base e. So e to what power is what number?
e to the 4th
Is what?
is x
X squared. X to the second power. X raised to the 2. E to the 4th is x squared. I want to get x alone, now what?
Take square root of both sides.
X is e squared? Not quite. Plus or minus e squared. Okay? Because the principal square root of x squared is really the absolute value of x. And the principal square root of e to the 4th is e squared. And if the absolute value of x is e squared, then x itself is either e squared or it's the opposite of e squared. So we usually skip from here to here, you add a plus or minus. A lot of times, as soon as you take the square root of both sides, you'll see teachers, you'll put a plus or minus in there. But in reality, you're saying these things are equal, they're positive, the principal square roots of both sides are equal, but the square root of x squared is not x, it's the absolute value of x. And if the absolute value of x is some number, then x could be that number, or x could be the opposite of that number. So x is plus or minus e squared. Okay? Is that it for 18, or is there another part of that? That's it. Okay? 42.
Here.
Peter, 42.
Graph the function on the same screen of the graph utility is the change of base formula where needed. 42. Derive the general change of base formula.
Okay. Go ahead. How do they say it?
Log base b of x
Log base b of x
equals log base a of x over log base a of b.
Okay, so we could change this into any base. Go to base q. I could go to base e. But that's it, base a. Could be anything. So we're trying to derive this change of base formula. We're trying to show that it's true. And did this back in Algebra 2, so I'll do it again right here. I'm going to say, let y equal the log base b of x. Therefore, what's true, Peter? Switch from logarithmic form to exponential form. Therefore,
so b to the y equals x.
okay, Now, we want to switch it. Instead of log base b, we want to go log base a. So let's take the log base a of both sides. If these two things are the same, and b to the y is a positive number, so we can't take the log of any positive number. So therefore, the log base a of b to the y is the log base a of x. You agree with that? What do we do now?
You can divide it over to,
No division, not yet, almost. Anyone know? Tyree?
Did you do the y exponent?
This y exponent moves where?
In front of the log.
Moves in front. We call it the third law of logarithms. So this is the same, I'll put it right here. Y times the log base a of b is the log base a of x. So I'm just going to rewrite it. Y times the log base a of b is the log base a of x. So then what, Peter?
they're divided.
We divide by what?
Log base a of b.
Divide by log base a of b. And y equal this, y equals that. Therefore, what we wanted is true by transfer probability of equality. Because y is equal to log base b of x, and y is equal to log base a of x over log base a of b. So y is both of these things, they have to be equal. Make sense? So that is something that you definitely should be familiar with. Does anyone remember if I have b to the x and I wanted to change it to base a? Anyone remember what the change of base formula for exponents is? Anyone remember that? I think it's on your demonstration sheet. Anyone know it? It's a to the x ln of b. Okay? Let's do if I go with let's see, y is b to the x. So how do I want to do this? I'm trying to think about how to prove this. Any thoughts? Help me out. All right. I need to get a base a in there. So let's take the log base a both sides. The log base a of y equals log base a of b to the x. Okay. So this comes down in front now, right? Log base a of y is x times the log base a of b. And now I go a raised to log base a of y is a raised to x log base a of b. And I didn't do this right. This is wrong. This should have been not ln b, but log base a of b. And you can see it right here. Because what's a raised to log base a of y? This is saying y. Yeah, the answer is y. What do you get when you take a and you raise it to the power you need to raise a by in order to end up with y? What do you end up with? Y. So y is a x log base a of b. So the y's are the same. So there it is. So b to the x is a to the x log base a of b. So for instance, if you had 10 to the z and you wanted to make it e to the something, it'd be e to the z times the natural log of 10. Be the same. So you can always change bases whether you're dealing with logarithms or exponents. We use this one more. That's sort of a nice one to know. It'll be later on the calculus course. It'll be a nice thing to know. All right. Let's look at number 56. Now, I'm pretty sure this is a homework problem. So, again, it could be a situation where if you've already done this, you might be able to pick up a little bonus. I'm not going to do it the entire way, but I'm going to give you some big hints on this. Who's up, Terry?
Really?
Billy, 56.
Suppose that the magnitude of two earthquakes differ by 1 on the Richter scale. Find the ratio of the released energy of the larger earthquake to that of the smaller earthquake. Note, see exercise 55 for terminology.
Okay, so here's the larger earthquake, and here's the smaller earthquake. And the magnitude of the larger is one more than the magnitude of the smaller. Okay, they told us that, right?
Right.
And what do they ask us to find? The ratio of the energies?
Yes, sir.
So we're looking, they want the ratio larger to smaller or smaller to larger, do they say?
Larger to smaller.
So we want energy of the second quake divided by energy of the first quake. That's what we want. So it's that easy. Somewhere in the text right near there, they're giving you the equation for earthquakes that talks about Richter scale. What's it say?
Log E equals 4.4 plus 1.5 m.
So if we take the log base 10 of the amount of energy, I'm not sure what the units are that they're using, it's going to be 4.4 plus 1.5 times the Richter scale number of the earthquake. Okay? Now, you guys know about Richter scale. Is 3 a real powerful quake? If it's 3? 3? No, you probably it's hard to even feel 3. Sometimes you'll feel it. Okay? What about 6? Buildings coming down when it's 6? Probably not with 6, but that's a strong quake. When you hit 7, then there can be damage. If you ever have an 8, it can be catastrophic. Okay? So we're going to see what happens with the ratio of the energies is when we're 1 apart. Because it's some kind of logarithmic scale, it's not like, 8/7. When you go from 7 to 8, it doesn't become 8/7 of the power. It doesn't even become 10 times the power. We're going to see what it is right here. And we do it this way. E2 to E1, let's just notice that this means that E is 10 raised to 4.4 plus 1.5 m. I went from logarithmic form to exponential form. We had log base 10 of E is this, so 10 raised to this exponent is the number E. Okay, so Billy, instead of E2, what can I write? Instead of E, I can write 10 raised to 4.4 plus 1.5 m. So in the case where I have energy in the second case, this is the larger quake, smaller quake. What do I write for E sub 2?
10 raised to the 4.4 plus 1.5, like a third, or like times 3, or times 2.
Actually, we're going to say M sub 2. Whatever the Richter scale number was, M sub 2. Okay, and what about E sub 1?
10 raised to the 4.4 plus 1.5 m sub 1.
Good. But what they say about M sub 2?
That it's 1 more than m sub 1.
So I'm going to cross that out, and I'm going to put M sub 1 plus 1 right there. Now, we're getting really close. The trick is going to be to use the fact that b to the m plus n is the same as b to the m times b to the n. We're going to go backwards with our laws of exponents. So this is the same as 10 to the 4.4 times 10 to the 1.5m plus 1.5. And the bottom is 10 to the 4.4 times 10 to the 1.5 m sub 1, period. I'm going to break this up even more, okay? By the way, Bailey, what happens to these?
They cancel.
Can I cancel these the way it's written? Well, what can I do? 2 choices. I want to simplify this somehow.
Oh, can you do like the things of second law exponents and subtract them?
Yeah, we can just subtract them, okay? In fact, we could have done that right here. We could have just subtracted this minus this. The 4.4 minus 4.4 would have been 0, would have gone away. We have 1.5 m sub 1 plus 1.5 minus 1.5 m sub 1 equals, we end up with 10 raised to what? What happens when you take this minus that?
those two will cancel, so you get 1.5.
And that's not something I know how to do in my head. 10 to the 3/2 power. Is the square root of 10 cubed. Can someone knock that out in the calculator? Was 10 to the 3/2. I think it's around 30.
31.6.
31.6. So we did the problem. We did number 56. When you go up 1 on the Richter scale, the amount of energies actually went up 31.6 times. It's 30 times as much energy released when you went from a 6 to a 7 on the Richter scale. So logarithmic scale doesn't go up 10 times, it goes up 31.6. It's this 1.5m that does that. If you had gotten that answer before we did in class, make a note of that, I'll give you bonus. Okay, so I have 5 review problems. In fact, go ahead and just stop the video going, just stop it.